Imagine sitting down to dinner tonight, and instead of a cooked meal, someone hands you a raw piece of meat and a fistful of raw grain. No fire, no softening, just biology versus food, closer to the raw food world our ancestors once lived in. You'd chew for hours. Your stomach would fight to break down what your teeth couldn't. And by the end of the day, you'd have taken in a fraction of the energy your body actually needs. That single missing invention, cooking, might be one of the quietest, most underrated turning points in human history. And if it had never happened, some scientists believe humans as we know them might not exist at all. So what if our ancestors had simply never learned to cook? To understand why this question matters, we have to go back to a problem every animal on Earth faces: energy. Every living thing runs on a budget. Calories in, calories out. And for most of evolutionary history, that budget was tight. Look at our closest living relatives, chimpanzees. In the wild, chimps can spend 5 to 6 hours a day just chewing. Raw fruit, raw leaves, raw bark, all of it tough, fibrous, and hard to break down. Their jaws are powerful, their teeth are massive, and their guts are long, built to slowly extract whatever nutrition they can from food that mostly resists them. Now compare that to us. Human jaws are small. Our teeth are modest. Our guts are shorter than you'd expect for an animal our size. On paper, we look poorly equipped to survive on raw food at all. So how did a species with such a weak digestive setup end up with one of the most energy-demanding organs in the human body, a brain that burns roughly a fifth of our body's total energy, despite being a fraction of our body weight? This is where cooking enters the story. Harvard anthropologist Richard Wrangham proposed an idea that's become known as the cooking hypothesis. The theory suggests that heat does something remarkable to food before it ever reaches your stomach. Cooking softens food, changes proteins, and makes starches easier to digest. In simple terms, cooking is a form of predigestion. The fire does part of the work your gut would otherwise have to do. If that's true, it means cooking didn't just make food taste better. It may have changed how much energy our ancestors could extract from every single meal, freeing up calories that could be redirected somewhere else, like fueling a rapidly growing brain. It's an elegant idea. It's also debated. Critics point out that clear archaeological evidence of controlled, everyday fire use doesn't show up reliably until around 1 million years ago, at sites like Wonderwerk Cave in South Africa. But the physical traits associated with a cooked diet, smaller teeth, a shorter gut, appear much earlier, in Homo erectus, close to 1.9 million years ago. That gap is real, and scientists are still working out how to explain it. One leading alternative points not to fire at all, but to simple mechanical processing. Early humans pounding, slicing, and mashing meat and tubers with stone tools, which can make raw food dramatically easier to chew and digest without any cooking involved. Under this view, mechanical processing may have paved the way first, with fire and cooking arriving later to finish the job. The honest answer is that we don't have the full picture yet. But let's run the experiment anyway. What if cooking, in any form, had simply never entered the human story? The first thing to go would be time. Chewing raw food isn't quick. Some researchers, extrapolating from primate data rather than direct measurement, estimate that a raw food human might need several extra hours a day just chewing, on top of the time spent finding and preparing food in the first place. That's hours no longer available for tool-making, socializing, exploring, or raising offspring. In a world without cooking, the average day might be consumed almost entirely by the basic act of eating enough to survive. The second thing to change would be the body itself. Without the extra, easily absorbed calories that cooking provides, there's less energy surplus to support an organ as costly as the human brain. This doesn't mean brains couldn't have grown at all. Evolution is rarely that simple, and diet is only one piece of a much larger puzzle that includes social complexity, cooperative hunting, and language. But many researchers who study human energy budgets argue that a raw, unprocessed diet alone would have made it far harder to fuel the kind of rapid brain growth our lineage experienced. Instead of the compact jaws and short guts we have today, a raw food human lineage might have kept something closer to the heavier jaw muscles, bigger teeth, and longer digestive tract seen in other great apes. Then there's the question of safety. Cooking does more than soften food. It also kills many of the bacteria and parasites that thrive in raw meat and unwashed plants. Without that protection, our ancestors would have faced constant exposure to foodborne illness. Some anthropologists argue that this alone would have quietly shaped human populations, since sickness from contaminated food could spread easily through small, closely connected groups. Life expectancy, already short by modern standards, might have been shorter still. Cooking may have changed more than biology. It may have changed how humans lived together. Around a fire, food had to wait. It had to be shared, portioned, and distributed rather than eaten on the spot the moment it was caught or gathered. It's one of the more speculative parts of this theory, but some researchers argue that this simple act, sitting, waiting, and sharing a cooked meal, helped lay the groundwork for cooperation, patience, and even early social bonding. Without cooking, meals might have stayed closer to how they look in most other primates, grabbed, eaten immediately, and rarely shared beyond a mother and her offspring. And then there's geography. Cooking doesn't just make food easier to digest, it makes more of the world's food edible in the first place. Many plants that are toxic or nutritionally useless raw become safe and valuable once heated. Many roots, tubers, and grains that later became dietary staples in colder climates become far more useful, digestible, or safe when cooked. Without that ability, entire categories of food would have stayed off the menu. Regions that later supported large populations because of grain agriculture and starchy staple crops might never have been worth settling in the first place. So picture the alternate timeline. Humans spending most of their waking hours chewing tough, raw food. Perhaps smaller brains, different bodies, different diets, and a radically different technological path. Populations kept small by illness and low-calorie diets. Migration into new environments slowed, not by cold this time, but by a lack of edible, high-energy food to survive on once they got there. Would some form of human still exist? Probably. Evolution rarely halts entirely. Other pressures, other adaptations, other tools might have stepped in to fill part of the gap. Cooking almost certainly wasn't the single cause of everything that followed. Bigger brains, denser social bonds, eventually civilization itself were shaped by many overlapping factors. But most researchers who study human origins agree on this much. Cooking, whenever and however it began, dramatically changed the energy economics of being human. It was probably one major piece of a much bigger evolutionary puzzle. It's strange to think that something as ordinary as flipping a piece of meat over a fire might sit at the root of who we became. But maybe that's the pattern with the biggest turning points in our story. They rarely look dramatic in the moment. They just quietly change the math of survival, one meal at a time. So here's the real question. If a single invention like cooking could reshape the trajectory of an entire species, what other ordinary habits might be doing the same thing today, without us even noticing? Let us know what you think in the comments.